Hi everyone. Thank you very much for being here to this session. Today we're going to talk about Detekt, State of the Union. Mandatory slide about myself. So my name is Nicola Corti. I'm a Kotlin Google developer expert, and I'm one of the maintainers of Detekt. I also happen to run a lot. I love running marathons, so if you are into running, please stop by afterwards. I would love to talk with you. Those are my contacts if you want to reach out afterwards. I also run a podcast. It's called The Developers Bakery. You can find it on Spotify, Apple Podcasts, Google Podcasts, whatsoever. It's about open source and tools for developers. So if you came to this talk, you will probably also like this podcast. So make sure you subscribe. But yeah, today we are going to talk about Detekt. How many of you here in the audience already used Detekt in the past? Awesome, because today I'm here also to collect some feedback from you. And I'm also here to tell you a little bit about this tool, how it works, and how to extend it, and what is coming next in the future of this project. First, I want to mention that we have a new project logo. I hope you like it, and I hope you get the reference of the double bang that we added in the logo of the project. But if you're not familiar with Detekt, so what is Detekt? Detekt is a static analyzer for Kotlin, and I would like to call it the static analyzer for Kotlin, because it's a community-driven project. We are around since multiple years. You can find us on github.com/detekt/detekt. And it's, for being a static analyzer, is quite popular. And we released version 1.18.1 end of August. We are going to release version 1.19 really soon. But the project is quite active, and we are constantly looking for contributors, people that gives feedback, and so on. At the time of writing this talk, Detekt offers 220 rules. So a rule is basically an inspector, something that takes in some Kotlin code, checks it, and tells, hey, here there might be a problem. So if you're not familiar with this tool, I actually want to spend some seconds telling you which type of rules we offer. And since there are so many, they are actually grouped into what we call rule sets. So we try to make sets of rules that are sort of meaningful. And I'm going to present some. So the first one is called comments. And as you might imagine, is all about comments, like documentation and like leaving comments to your code. Then we have another rule set called complexity. And the rules in this set are trying to understand if the code you wrote is too complex, or it's hard to read, or can be simplified. Then there is a rule set called coroutines. And here we have rules that are specific to the coroutines word, so how you use coroutines and so on. Another rule set is called empty blocks, and checks if there are empty blocks. Some of those rule sets are like self-explanatory. We have exceptions, like rules to check how you use exceptions, if you raise them, if you catch like too wide exceptions, and so on. Naming, rules about like how you name your variables, your classes, and so on. Performance, so there might be sections of Kotlin code that are not really performant and they can be improved. So we have some rules for those. And another rule set that is quite big is potential bugs. So maybe like accessing variables that should not be accessed, and so on. There might be code that can lead to a bug. So we have rules for those. But the rule set is actually potentially the biggest is the style one. And here we have a lot of rules that helps you basically write clean code. So making sure that you use immutable variable if you don't like mutate a variable, and so on. I want to take some to give some examples. So those of you that already use Detekt already know how the tool works, but there might be some that is not familiar with the tool. So let's take a couple of them. The first one is called unused private member. self-explanatory again. It just checks if there is a private member, there is a news. For example, if I have this code, and I have two members, a member and another one, and I have a function, I just print one. Detekt will tell me, hey, private property, another member is unused. So maybe you want to remove it. We have another rule called magic number. I heard a lot of people are unhappy with this rule. So today I'm here also to understand why you folks are unhappy with that. And magic number goes to check if you have number in your code that are hard to understand for a reader. For example, in this case, you might compare an integer with like number 42, and Detekt will tell you, hey, this expression contains a magic number. Consider defining it to a while-named constant, like export it to a constant, and whoever reads that will better understand why you have 42 there and not 41 or 43. All the rules that we have in Detekt are documented. So either you open the source code of the rule, and other than having like a small documentation, we always provide like a non-compliant block and a compliant block, where we provide snippets to showcase like, hey, this code is not great, you should replace it with this other code. For every rule, we also specify if they are activated by default or not. Because we provide 200 rules, but we don't enable them, all of them. So we enable only those that we believe are valuable for the majority of our users, but there are others that you might necessarily like activate. They are disabled by default. So all this information is in the source code, and it's not really easy to consume. So we also have a website where you can find all the information for a rule. In this case, like active by default, all the configuration parameters. For example, this is the magic number one, and we have like ignore numbers and so on. Like you can configure the behavior of the rule to adapt it to your code base. And the snippets, the compliant and non-compliant snippets that we saw before. So I briefly touched on configuration, how you configure Detekt. So you provide a YAML file where you specify how those rules should behave. It's a YAML file that stays in the top level of your project. And there you can configure rules. So for example, if we go to the magic number, you can activate or deactivate a rule. And you can specify like numbers that should be ignored, or the hashcode function should be ignored, or so on. Let's take another couple of rules that are a little bit more complex, because I want to deep dive a little bit on how Detekt works internally. So one rule is called unnecessary not null operator. And let's take this example. So I have a val 0 equals 0, and I have an answer that is 0 plus 42. If I change this code to this one, and I add a double bang, well, that's not needed. Like, for you as a reader that you read this code, that's not needed. But why you're able to say that? You're able to say that because there is a val 0 equals 0. The type is inferred to be int, non-nullable int, so we don't need a double bang there. So this is like a little bit of a subtle type of analysis, because we need to know the type of 0. It's non-nullable int, so we can make a call at that operator and say like, hey, 0 double bang contains an unnecessary not null operators. So here I started to introduce the concept of types. All the rules we saw before, like magic number, is a rule that works only at the syntactic level of the language. It just checks if there are numbers in your code. This rule, instead, is a little bit more advanced type of rules, because this needs to resolve a type. Needs to know what's the type of the variable called 0. In that case, it's easy, because you are declaring the value there equals 0, so we can infer the type there directly. But there might be scenarios that are a little bit more complex. So another rule that I also want to point out that is really cool is called double mutability for collection. That's actually one of my favorite. And here, like in this section of code, we have like var obits equal mutable list of and some obits. So here, there is a problem. What's the problem here? The problem is that we have a var, and we also have a mutable list. So you are basically introducing a double mutability there. And Detekt will tell you variable obits is declared as var with a mutable type, mutable list. Consider using val or an immutable collection type. You can still mutate that if you have a val or if you have a var with a list of. I just want to point out that this is one of the rules from the effective Kotlin. Marcin is in the audience, so ask him if you don't agree with this. But yeah, just to point out one little thing. We do have a lot of content in the Kotlin community, like a lot of amazing articles, books, and so on. But how many times you actually read a book, you read an article, and you say like, oh yeah, that's amazing. Like, it's something that I want to add to my code. Like, it's something that I need to remember whenever I write code so that my code is cleaner. But you actually fail to do that because you maybe forgot, or maybe your code base is too big. Detekt is bridging the gap in this spot. So Detekt allows you to automate those patterns and find problems and patterns in your code that should be removed or should be adapted. So we have another rule. It's called forbidden method call. This is a rule that is disabled by default. As I said before, we don't enable all of them. And this is one of the rules that we intentionally disable. In this case, for example, like if you see the config file, you will find that this has active false. And there are a list of methods, println and print. So what is this rule doing? This rule is checking if you're making a call of a method that is one of the methods described in this list. When this can be useful? Well, it can be useful if you want to prevent people just using print line in your code, because maybe you have a logger, or you have like some more advanced printing capabilities, and you just don't want user to use println. Or maybe you have your own function that you don't want your developers to use. And you can use this rule, provide the fully qualified names of the methods that you want to block, and this rule will help you. So maybe if you are like in a small startup or in a small team with 4 or 5 developers, you just go through your code and you adapt it and you remove all the method codes that you don't want. But if you work in a bigger organization with like 50, 100, or more 100 engineers, you need tools like this to block method calls, to block imports that you don't want people to use. And so, yeah, in this case, println, Detekt will tell you the method Kotlin IO println string has been forbidden in the Detekt config. So you can't use it. Obviously, there are false positives and false negatives. So there might be scenarios where Detekt reports something, and you know as a developer that in that specific line, you are good. Like, you're fine suppressing. So how do you do that? This is really similar to how lint, Android lint is doing this. So you can just annotate @suppress and provide the name of the rule. And this annotation is really modular because you can either apply it at the line level, at the block level, or at any nested block, like at the function, or even at the top level using the file qualified annotation. So how do you use Detekt? So Detekt is a tool, but it's actually an ecosystem of integrations and tools for various platforms. And today I want to mention some, because I believe that a lot of users are using the Detekt Gradle plugin, but we actually have a lot of different ways to use Detekt. So the potentially easiest, or more like vanilla way to use Detekt is to get Detekt CLI. So for every release that we do of Detekt, on GitHub, you will find attached a CLI file that you can just like invoke. And we are also available on Brew. So if you do brew install Detekt, you will actually get the CLI, and you can just call Detekt and give it a Kotlin file, and you can pass all the configuration you want, and so on. Obviously, if you have an Android project, that's not so convenient. That's why we also provide a Gradle integration for that. I mentioned briefly that you can also extend Detekt to provide your custom behavior. And that's where I believe a lot of the power of Detekt comes in. So to talk about custom rules, I actually want to talk about one group of custom rules that we, Detekt maintainers, already provide to the community. And this set of custom rules is the Detekt and Kotlin integration. So I intentionally wanted to add this slide because I know there is a little bit of confusion between Detekt and Kotlin, and the naming here doesn't really help. So Kotlin is a formatter. It's not a linter. Naming is hard. But Kotlin effectively reformats your code. Detekt is a linter. So Detekt actually checks if there are bugs or so on. We actually allow to run Kotlin within Detekt. So we provide basically a wrapper. You can just use Detekt and run Detekt and Kotlin. So we offer a custom rule set called Detekt formatting, and we have one rule for every Kotlin rule. And yeah, so in the this is not loading. Yeah. So those are the list of the rules. There are the Kotlin wrapped rules that we offer as part of the Detekt formatting rule set. Those, by the way, are the only rules that are offering the autocorrection capability. So as part of, so Detekt offers the capability to do autocorrection, but we, Detekt maintainer, decided to don't touch your code. So Detekt will just look at your code and will tell you, hey, there might be a bug here, there might be a bug there, you need to fix it. Kotlin instead is a formatter. So Kotlin just checks that there is like a white space and remove it for you. So that's why those are the only rules that are offering the autocorrection capability. We actually delegate to Kotlin to do the autocorrection. So we don't edit your code. This creates a little bit of confusion, because there are rules that offers similar behavior, and some of those rules are Kotlin rules, and other of those rules are Detekt rules. For example, here we have one. The wildcard import is a Detekt rule, and the no wildcard imports is a Kotlin rule. So sometimes people tell me, hey, yeah, I run my code and I have like things reported twice, and that's so confusing. And that's actually, I mean, that's how you configured your tool. Maybe you enabled all the rules, and you enabled a Kotlin rule that is checking for wildcard imports, and then you also enabled a Detekt rule that is also checking for imports. So that's why you have those double reporting. Detekt rules are generally more granular. So they offer, like in this case, an exclude imports or other configuration, while the Kotlin are more basic. And on the other hand, sometimes they even offer autocorrection that Detekt doesn't. For example, the unused import. So there is the unused import Detekt rule, and no unused imports Kotlin rule that also autocorrects the rules. But if you need, and probably I spoke with a lot of people that actually did this, you might write your own custom rules. So how do you write a custom rule for Detekt? It's quite easy. So you need to create a Kotlin JVM module, so like a Java library kind of thing. And you need to provide three things. First, the rule. So the rule will be a like my custom rule will be a subclass of our rule type, and you will get a config object where you can like read the config keys, and inside this class you will provide the body of your rule. Then you need to provide a rule set provider. So you need to define a rule set where you specify all of your rules. In this case, there is only one, but you might have more. And we use the service locator pattern to load these rule sets. So you need to have a file in the meta.inf folder with the fully qualified name of your rule set provider. And how the custom rules are working. So we do have a page specifically on how to write custom rules. But it works with the visitor pattern. So it means that inside the body of your rule, you can override one of the visit method. For example, if your rule is checking the function name, there will be a visit function declaration. And then there you have a reference to a KT function, type of object. And then you can check what's the name of the function. So here is where the gray area starts, because here we start touching the Kotlin PSI API, and a lot of people tell me, hey, I have absolutely no idea about how to do this. There is no documentation at all. And well, that's a little bit on JetBrains' side, because this API is quite big. Like, working with the Kotlin source code is not super easy. But the way that I can recommend to start in this space, if you're interested in writing your custom rule, is to search inside Detekt if there is a rule that is similar to the one you want to implement. So maybe you're looking into forbidding the I don't know, the access to a property. Then you will find a rule that is called forbidden method call, and you will try to take inspiration from there. Also, we are extremely supportive on GitHub issues, on Slack, so just drop us a message. It's full of people that already wrote rules in the past, and we can help you write your custom rule. I want to now touch a little bit on the integration side. As I mentioned, Detekt is more than just a project. It's an ecosystem. So we do have a lot of other tools and plugins that we maintain, and it's actually a lot of work. But yeah, we're proud of what we achieved so far. So there is an IntelliJ plugin. So if you use Android Studio, IntelliJ, or any other IDE from JetBrains, you can install it. You will find it in the store. And yeah, you can just configure Detekt over there, and it will run the inspection in the code. So you will also have those yellow warning boxes around the code that is reported as inspected by Detekt. We also recently released support for Sarif. So if you don't know what is Sarif, Sarif is an acronym that stands for Static Analysis Result Interchange Format. And so this is like, it's basically like a default format for static analyzers. And you can find the website over there, and there is a specification on how static analyzers should output their findings. So before these, you could just like get an HTML report, or an XML report, or a TXT report. So we added this new format. And why this is relevant? Because GitHub has native support for Sarif reports. It means that if you wire everything, you can basically go on GitHub, and whenever there is a pull request, you will see inline comments in the code scanning tab, and there will be like detect issues, and what is the description of the issue. Another integration that we have is with SonarQube. So if you're using SonarQube, is like a static analysis service. You can plug in the Detekt Sonar plugin and have Detekt inspections over there. Also, if you saw the Kotlin 1.6 event 2 days ago, JetBrains announced Kodana. So we are looking into maybe providing a plugin for Detekt. That's completely green space for us. So if you're looking into contributing with something new, please drop us a message. So briefly before, I talked about types. And now I want to clarify a little bit on type resolution. So as I said, magic number is a rule that works at the static level. So it just checks the file that you send and is able to say, like, oh, this is a number, this is a string, and so on. While the other rule I presented before, unnecessary not null operator, needs to know a little bit more about your software and about your code. So in the case over here, it was easy, because we could infer the type of the variable called 0 directly from the code. But if you have something like that, get a number, what is the type of 0? Well, I don't know what is the type. I might say, like, yeah, this can be an int or a nullable int. Who knows? Or it can be any, or it can be, I don't know. So the problem is that at this stage, a necessary not null operator needs to know the return type of getANumber to run that inspection. Without types, Detekt is not able to tell you if the double bang is needed or not. So that's why we are starting to introduce rules that works with type resolution. And those rules are annotated with @requires type resolution. And those rules access an object that is called binding context. I don't want to deep dive into this too much, but all the rules that are running with type resolution, they all have this statement. They check if the binding context is empty, and if it's empty, they return, and they don't run the inspection. That means that if you want to write a custom rule that runs with type resolution, you need to add the same block. And if types are not available, that inspection will not run. Like a lot of issues that we receive on GitHub are like, hey, like I enabled this rule, but it just doesn't work. And most of the time, the answer is like, hey, type resolution is not enabled, so this rule will never run. So as I said, the type resolution annotation also ends up in the documentation. So in the website, you will find if that rule requires types or not. And how do you actually use it? This was a question that we received a lot of time. That's why we also wrote an entire page on it. And like the initial way was like, hey, you need to go on Detekt CLI and provide like class path and a Java level kind of thing. And the class path should be the list of all of your dependencies and so on. And people said like, the what? Like, what do you want from me? What do you want a class path from me? That's why we offer Detekt Gradle plugin. Again, I don't want to deep dive too much into this, but the problem is that getANumber function might be a function in your code, or might be a function from Retrofit or from OKHTTP. So Detekt needs to have those libraries in the belly to know what's the type of all of those functions. So we need to have all of your dependencies to run Detekt with type resolution. That's why we offer Gradle integration. You don't need to specify the class path to us. We are going to take it for you. So we offer Detekt Gradle plugin. You just apply it as a plugin with ID and the version. You need to provide, obviously, we are on Maven Central and on Gradle Portal. So we suppose like everyone can use us. And you have this Detekt configuration block where you can specify where your config file is and so on. So in an empty project, if you run Gradle tasks and you search for Detekt, you will find 3 tasks. Detekt, that will just run Detekt. Detekt baseline, that will create a baseline file. And Detekt generate config, that will create the configuration file, and like a blank configuration file for you. That's useful, but generally you apply Detekt to an Android project or to a Java module or to a multi-platform module. So if you have a Kotlin JVM module and you run Detekt again, you will find that there are more tasks. So the convention that we decided to follow is the Detekt task, the plain Detekt, is the one that runs without type resolution. So if you just invoke Detekt, no types will be resolved. Those other tasks, like Detekt baseline main, Detekt baseline test, and Detekt main and Detekt test, those are tasks that runs with type resolution. So in this case, we go, for example, for Detekt main, we go in the main source set. We get all the dependencies for main, and we run Detekt with type resolution over there. Looks simple, but when you add Android, things get a little bit more complicated, because you have a Gradle file that is like that. You have Kotlin Android, you have command write application or command write library, and so on. And then you start to search which tasks you have for Detekt, and you realize, oh, they are a lot. So you have baseline debug, baseline Android test, blah, 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 Detekt debug Android test, Detekt debug unit test, and so on. That is the problem. I don't know how we should call it, but the fact that Android has build types, has variants, and so on. And for every build type and for every variant, you can have different dependencies, and so on and so forth. So we follow this approach. This is the same approach that actually Kotlin and other static analyzer and formatters are doing. So we create one task for every build type that you have at the end. And so on and so forth. We also released recently support for Kotlin Multiplatform. So if you apply Detekt to a multi-platform project, you will have like multiple targets, like JVM, Android, iOS, or JS, or whatever. And yeah, at this stage, if you run task and you grep for Detekt, there are several. And this is sort of experimental. We are looking for feedback for people using Detekt in a multi-platform world. Like we already received a lot of good feedback, like tasks that they don't make sense or they don't include the correct source files. So please let us know if this works for you or it doesn't work for you. And now that I'm close to the end, I actually want to talk a little bit about the future. So what we are baking, what is coming next. So version 1.19 is really near. And I want to point out a couple of features that have been highly requested in the community, and we are working on that. But again, we need your feedback. The first one is the ignore annotated, and generally also other more fine-grained controls for ignoring section of your code. For example, this magic number rule. A lot of people report that, yeah, I started using Jetpack Compose, and when I specify dimensions, I use numbers, and I have magic number everywhere in my code. That is super annoying. So now we allow to specify an ignore annotated key on all of your rules, and you can say which annotation you want to be considered. So the rule will run, will find like in findings in your code base, and then we'll check if there is an annotation in one of the block in the hierarchy that is the annotation that you specified there. And if that is the case, that finding will not be reported. We are looking into extending these capabilities with other like way to ignore, for example, the function names or the class names. Maybe, for example, we had a lot of reports in the past that for Dagger, when you have a class called in a certain name, there are rules that don't make sense that they run in that context. We stick to having Detekt as platform independent as possible. We don't want to bake inside Detekt knowledge of Compose, knowledge of Dagger, knowledge of Spring, knowledge of any framework, because I mean, most of you are Android engineer, but Detekt is used a lot also in the backend world. And we want this tool to be a Kotlin tool, but platform agnostic. And another thing that we are shipping is a deprecation of the reports block. So nowadays, on Detekt, you can specify where reports should end up. And you can enable or disable. Like, for example, you can say that you want the XML one, and you want it in a file called detect.xml. So the problem with this code is that every task, and we saw there are a lot of them, every task will get their information. So every task will just write on detect.xml. And the last task that will write in that file is the one that you will actually see. So they basically end up overriding each other. And this was a design that was done in the early days of the Gradle plugin, and it worked when there was only the Detekt task, but it doesn't scale for us anymore. So you will need to configure the reports at the task level. And now I also want to talk a little bit more about the broader future of Detekt. So nowadays, what you do, if you call the check Gradle task, where all the tests and all the verification tasks are hooked in, you will also call compile Kotlin, because a check will also call build and so on. And you will also call the Detekt task, the one without type resolution. The Gradle plugin just adds this arrow. But we want type resolution to be the default, because rules with type resolution are the more powerful one. Like, we can provide more advanced analysis if we have types. So that's the ideal state. It's not there yet. You need to connect those tasks if you want to. The problem of running with type resolution is that type resolution is more heavy from the performance point of view. Like, it takes more time. The without type resolution run is just like checking the syntax of your code, and it's fairly easy. The other needs to have all the dependencies and resolve types and so on. So we are effectively running another Kotlin compilation when we run Detekt with type resolution. And that's not ideal, especially because you already compile, like you do compile Kotlin, and you also run Detekt main. So we are compiling twice. And there is also another subtle problem that sometimes those two compilations end up having slightly different compiler flags. So we would like Detekt to have a vision of your code as close as possible to the Kotlin compiler vision. And so, like, there are paths that are sometimes harder to compute correctly. Like, if you use view binding on Android, you will see a lot of warnings. It's not great. So we are working on the Detekt compiler plugin. So our vision is to have Detekt plugged in the compiler. And at that stage, the compiler will already give us the intermediate representation of your code, and we can see the types. We don't need to compile twice. From the user perspective point of view, now you have something like this, where you specify the Detekt configuration. And ideally, what we will ask you to do is just to change the ID of the Gradle plugin. Everything will work. We hope so. Or we are trying to make this migration as smooth as possible. So this means that when you will call Gradle check, you will call compile Kotlin, and compile Kotlin will load all the compiler plugins, and we are there. So we can run Detekt and see the types and have all the information over there during the compilation. So we are not double compiling anymore. We have types, and those types are as close as possible to the production code. And we don't need all those extra tasks. We don't need detect, debug, unit test, and so on, because Kotlin is compiling your unit test. So we are there. And this means that when you call Detekt on your terminal will look like this. When you call assemble and you have all the warnings, you will also have a warning or an error for Detekt that tells you, hey, at this line, I found something. So that's where Detekt will run, hopefully, in the future. Now it's just a couple of closing words about us, the community. So where is Detekt? Where you can get in touch with us? So on the Detekt on GitHub, we have a channel called Detekt on Kotlin Slack. And the website is detekt.github.io. Please open discussions or GitHub issues. We are trying to answer everyone. We also have a contributing file. That's where you find some suggestions on how to start. And how to start. A lot of people keeps on asking me, how do I do open source? What should I do? So search for issues labeled as help wanted. We have tons of them. We literally don't have the time and the bandwidth to do everything. So there is plenty of stuff to do. There is a documentation to be updated. There are tests that are missing, submit new rules ideas. Find false positives and false negatives that needs to be fixed. Help with integrations. Maybe you are great at doing IntelliJ plugins. That's where we need you. Test new versions, like snapshots. Test the new one that is coming out. Tell us if it's broken or so. And we also need a lot of help on branding and marketing. We don't have a Twitter account. We just got a logo. We need to redo our website. We have a bunch of things to do. So please, who is Detekt? Detekt is the community. I think that's amazing because there is no company here. Like, it's just 200 plus people that wrote rules over the years. And we want your help as well. And because of this, I also have a giveaway now. So, little side note, I was running a marathon recently, and I was like giving away some stickers. So I have those amazing sticker sheets that I would like to give away. And I know you all want this. It works on my machine or other stickers. So I'm going to give away one of these sticker sheets, till I have them, to every pull request that is open on Detekt today. I'm here at the conference. Check the code, find typos, do whatever. The meaningful PR, please don't add emojis to the README, because those will not count. But think about us, and yeah, thank you very much, and let's make Detekt amazing. Those are my contacts. You will find me on GitHub or on Twitter as Corti Nico, and thank you very much for listening.